is the spec for the product rule. Product rule. And in this module, we're just going to make each function the product of two other functions, or maybe more. And then they're going to have to find the derivative. So we might have an example like f of x is equal to, maybe we'll put a polynomial here. So x squared plus 2x times, and we could either put another polynomial, or we could put one of our special functions there. So times, I don't know, let's put times cosine of x. Times cosine of x. And then we would say f prime of x is equal to question mark. Or if we had y is equal to that, we'd say dy dx is equal to question mark. Or y prime is equal to question mark. And so the first hint we could say is f prime of x is equal to, okay, we should use the word product rule. So by the product rule, by the product rule, f prime of x is equal to the derivative of the first function, d dx of x squared plus 2x times cosine of x plus x squared plus 2x times the derivative, d dx, of cosine of x. They click hint again. We get derivative of x squared plus 2x is equal to 2x plus 2. And maybe in that same hint, it doesn't really matter. We'll also say the derivative dx of cosine of x is equal to negative sine of x. And then they click hint again, and then they say, so f prime of x is going to be equal to 2x plus 2 times cosine of x plus x squared plus 2x times negative sine of x times negative sine of x. Or, and if we want to simplify it completely, we have f prime of x is equal to, we could write 2x plus 2 cosine of x minus x squared plus 2x times sine of x. So either way, and if we want, we can color code things. We could put this, maybe we put that in orange, and that would be in orange, and then this would be in orange, and so you'd put this in orange, and then maybe you could pick some other color for this. Maybe the cosine of x, could be in blue, and so you would put it right there, so they see where things are coming from. But that would be one example of the product rule. We could also give more involved ones, maybe the product of three things, just so that students can see how to extend this beyond just the product of two functions. So we can do something like, maybe we could say y is equal to e to the x cosine of x times, or maybe I'll do e to the x, x to the third. Maybe I'll make it, yeah, let's make it e to the x, x to the third sine of x. And then we're going to say y prime is equal to question mark, or we say dy dx is equal to question mark. And we could say by the product rule. By the product rule. Product rule. And if you take the product of three functions, this is about as far as I've ever had to do. I mean, you could do it with 4 or 5 if you have to. But by the product rule, dy dx, or y prime, is equal to the derivative of e to the x times x to the third times sine of x plus e to the x times the derivative of x to the third times sine of x plus, hopefully we have enough space when we do it, e to the x times x to the third times the derivative of sine of x. And then just like we did in the last one, we could write the derivative. So the next hint would be d dx of e to the x is equal to e to the x. D dx of x to the third is equal to 3x squared. And d dx of sine of x is equal to cosine of x. And we could color code it if we want. We could maybe write this in orange, maybe that in orange right there. Maybe we somehow we show that this is in blue, so we show this in blue, and then maybe we show this in magenta, and then we show that in magenta right there, so that students see where they're coming from. And then the last hint, so we have dy dx is going to be equal to e to the x, x to the third sine of x, plus 3x e to the x times 3x squared times sine of x, plus e to the x, x to the third cosine of x. And we can still keep things color coded. So this right here will be the orange, this right here will be the blue, and then this right here will be the magenta, just so that students realize that, look, we're taking the derivative of each of these and multiplying it by the other two terms. And then and there are three terms because each of them get their chance. And then when we write the answer, the more simplified we can write this, the better. But we don't have to, because we're really not testing whether people can simplify algebraic expressions. If because of the implementation, this is just as far as you want to go, this could be the answer. We don't have to force people to simplify it as much as possible. So in general, so let me clear this again. Just as many functions of that variety as you can. Make the other things look like they could be the answer, even though obviously they shouldn't. If you want to get extra fancy, make them look like possible careless errors that someone might make. And you could just use a combination of polynomials, e to the x, natural log of x. So, we could ask them, um, and if we want to mix it up, we could say g of x. Well, we could just say f of x if it becomes too hard to implement. But g of x is equal to, e to the x ln of x. And then same thing, by product rule. By product rule, g prime of x is equal to the derivative of e to the x. Always want to put that in brackets just so you know that's the derivative operator, times the natural log of x plus e to the x times the derivative of natural log of x. And you know the drill. The next hint, write what the derivative of e to the x is, it's e to the x. Write what the derivative of natural log of x is, it's 1 over x. And then you have g prime is equal to e to the x times natural log of x plus e to the x times 1 over x. Same drill over and over again. But you have two or three functions here every time, and the two or three functions should be either and we don't want composite functions, so it should just be straight up e to the x natural log of x, sine cosine of x, or it could be a polynomial of some type. Because going into this, that's all we're going to assume. We're assuming students do not know the chain rule. We'll save that for the next module.